Problem E2S2 says, a square with sides D has particles with charges Q, 2Q, 3Q, and 4Q arranged clockwise around the corners of the square. What is the magnitude and direction of the electric field at the square's center? And it says, hint, consider pairs of particles on opposite sides of the square. Choose a coordinate system that makes finding the field vector's components easy. So right off the bat, you might think about doing it this way. Drawing a square, and then putting the charges here. Right, that would be your first attempt at solving this problem. But the problem is, let's just look at this charge right here. Let's start here. Let's call this one 1. And if I want to use the displacement vector, so R1 is going to be, now I know that this side is D, and if the origin is at the center, then this is going to be D over 2, and this is going to be D over 2. So my vector for this location, right, from the center to this location, I'm going to have D over 2 and D over 2. So I'm going to have D over 2 and D over 2 and 0. And if I look at this charge right here, my R2 is going to be D over 2 minus D over 2, oops, and 0. And on I'll go around the square. But they tell me, hey, notice that you can pick your own coordinate system, and you can pick it so that you can find the field vector's components easily. So how about, instead of that, since they tell us that, how about if instead we put the charges on the axes, because that really does make our life easier in terms of finding the displacement vectors. So we'll call this one Q1, and we'll go around the circle clockwise. And so we know that this is D, this is D, this is D, and this is D. So if I want to find R1, then I know that if this is D right here, then I know that this over here, this is what let's see, this is Q1. I'm looking for, we'll call this R. And the way I can find R is I can say that these two sides are the same. So R, this is equal to R, and this is equal to R, and they're both the same. So I know that R squared plus R squared is equal to D squared. And so if I'm looking for R, 2R squared is equal to D squared. So R squared is equal to D squared over 2. And so R is equal to D over the square root of 2, which is also equal to the square root of 2 over 2 times D. So that's how I find that. And that's probably the hardest thing about finding this. So I have to do this once, and then I can use it for all of my positions here. So for my X position for Q1, I'm going to have 0, and I'm going to have my Y position is just my R, so that's the square root of 2 D over 2 and 0. If this is my charge number 2, Q2, I'm going to have R2 is equal to, now here I have my R, so that's going to be the square root of 2 D over 2 and 0, 0. It has no Y. R3 is going to be this location here, and so I'm going to have 0, and now I'm going to have a minus the square root of 2 over 2 D, 0. And R4 is equal to, and this now I'm going to have, this is going to be a negative, so a negative in the X, a negative of the square root of 2 over 2D, 0, 0. So I've found all of my my displacement vectors pretty easily. So that's pretty easy. Now let's go on to the next slide. Now if you want to calculate the electric field at P, so EP is equal to EP due to 1 plus EP due to 2 plus EP due to 3 plus EP due to 4. And so, so P, if I'm going to write the vector RP1, remember that's RP, the vector RP minus R1. And so RP, right, that's actually, if I think about the location of P, that vector is going to equal 0, 0, 0. because it's located at the origin, minus, and then R1 is 0, and the square root of 2d over 2, and 0. So I end up with RP1 equals 0, and then a negative square root of 2d over 2, and 0. And so for RP2, I'm going to have the same thing. RP2, I'm going to have 0 minus this vector, so that's going to equal a negative the square root of 2d over 2, 0, 0, right? Because 0 minus, and this would be negative here, and then RP3 is equal to my zeros minus R3, so I'm going to have 0, and now this is going to become positive because 0 minus a negative becomes positive, and RP4 equals 0 minus that, so I'm going to have a positive in the x direction. Okay, so now when I write this out here, remember that my EP is going to be KQ1 over RP1 cubed in the RP1 direction, and then that's going to be true for each one of these. So I'm going to have 4 terms that I need to figure out here. So, okay, I noticed that my RP4, I had a negative here, but it's actually a positive because I have P is at 0, 0. And so when I say 0, 0, 0 minus a negative, the square root of 2d over 2, I'm going to get a positive. So 0 minus a negative gives me a positive. Okay, so now to calculate my electric field due to each one of the charges, I'm going to use KQ over the square root of 2 times d over 2 cubed. And now this is going to be R1. So this is the magnitude of RP1, right? So RP1 is this magnitude right here, the magnitude of this vector, and so I know that's going to be the square root of 2d over 2, because that's what R is equal to. And now the direction, we're going to write this vector in that spot. So negative the square root of 2d over 2, 0. Now I'm going to do the electric field due to charge 2, which is 2q. So now I'm going to say 2q over the square root of 2d over 2 all cubed. Now I'm going to put in that vector, this vector here. So I'm going to have the square root of 2d over 2, and that's a negative, 0, 0.